So the aim of this segment is to study the synchro transmitter and receiver pair. Okay, so in this segment, the apparatus required are, we need a synchro pair, we need a digital multimeter, we need some patch cords to give connections. So in this segment, we have two parts. One part is we will note down the voltage across the synchro transmitter across each winding. Okay, you can see here it has three windings here, S1, S2 and S3. So initially, by varying the angular position of the rotor of this synchro transmitter, okay, so we'll note down voltage across S1, S2 with the help of digital multimeter. We'll note down voltage across S2, S3 and voltage across S3 and S1 with the help of digital multimeter. That is one experiment. Next experiment is we will connect the here this is the transmitter, synchro transmitter, and this is the receiver. We will connect the windings of the transmitter and receiver with the help of patch cords. We will connect S1 to I'm sorry, this is S1. S1 of this transmitter is connected to the S1 of receiver. So for more clarity, we can denote this receiver terminal S1 as S1 dash. So S1 must be connected to S1 dash. So let us assume that these winding terminals of this receiver are S1 dash, S2 dash and S3 dash, and these winding terminals of this transmitter are S1, S2 and S3. Okay, so these winding terminals, just let us denote for this transmitter as S1, S2 and S3, for receiver as S1 dash, S2 dash and S3 dash. Okay, so S1 must be connected to S1 dash, S3 must be connected to S3 dash, S2 must be connected to S3 dash for determining the angular error. Okay, so angular error, in order to determine the angular error between the transmitter rotor and the receiver rotor, we are going to conduct this experiment. Okay, so here we are going to do the experiment on synchro pair in two parts. One is to determine the voltage across across the windings of this transmitter. Another one is to determine the error in between the rotor angles of the transmitter and the receiver. Okay, so in order to go into the procedure, okay, so let us see what is this synchro pair looks like. Okay, so in your laboratory, so this image is not the exact equipment which is available in the laboratory, but it is somewhat similar. That's why I have included in this slide. If you see, this is the rotor of the this indicator. Okay, so this indicator, this dial type indicator shows the rotor of the transmitter. This dial type indicator shows the receiver of the transmitter. I'm sorry, receiver of the synchros. Okay, not transmitter. This is the transmitter, this is the receiver. Rotor, these two dial type indicators show the angular positions of the transmitter and the receiver. Okay, so this indicator shows the angular position of the transmitter, this indicator shows the angular position of the receiver. Okay, so this is the rotor of the transmitter, this is the rotor of the receiver. Okay, so as the angular position of the rotor of the transmitter varies, okay, so this indicator shows the angular position of the transmitter. Actually, in this experiment, we are going to manually vary the angular position of the transmitter rotor. Okay, so what is the angular position of the this rotor of this transmitter is indicated by this dial. Okay, similarly, the angular position of the rotor of this receiver is indicated by this dial. Okay, so these are the angles you can see clearly in this image. See, 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, and so on up to 360. 0 to 360 degree angular displacement angles are displayed on this synchro pair. Okay, so this is our transmitter. This is our transmitter. This other side of this is the digital multimeter that you require to note down the voltage. Okay, this is our digital multimeter. On the other side, on the right side, there will be a receiver. Okay, so that is this receiver will be there. Okay, so in our just now you have seen here, these are the windings, stator windings of the transmitter S1, S2 and S3. Okay, and these are the stator windings of the receiver S1 dash, S2 dash, S3 dash. Okay, of course it is showing here S1, S2, S3 for more clarity. Let us assume that this is S1 dash, S2 dash and S3 dash. Okay, so these winding terminals S1, S2, S3, you can see here in this image. If you just carefully observe, this is S1, S2 and S3. I will zoom this image. I hope you are able to see now. This is S1, S2 and S3. Okay, of the stator of our transmitter. Okay, on the other side, okay, on the other side, for stator terminals of your receiver, of course in that image also it is written S1, S2, S3. Here also it is S1, S2, S3. Okay, for more clarity, if we write S1 dash, S2 dash, S3, in your observation you might have written S1 dash, S2 dash, S3 dash. Okay, so these are the stator terminals of the receiver. These are the stator terminals of your transmitter. Okay, okay, now so let us see the procedure initially. So first we will first procedure is to study the synchro transmitter. Okay, so now to study the synchro transmitter, so first of all what we must do is we must connect the main supply to this synchro pair or synchro transmitter receiver pair kit. Okay, so in our laboratory, synchro transmitter receiver pair kit will be there. This is the kit which is available in our laboratory. Okay, to this plug, a main supply plug will be given. You must you must give main supply connection to this. Okay, so you can see some patch cords here. With the help of patch cords, this is our digital multimeter which is inbuilt. Okay, you don't have to connect any digital multimeter separately to this kit. Okay, so this is the inbuilt digital multimeter. So these are the voltmeter knobs. Okay, since you have to note down the voltage. Okay, so from this voltmeter knob, okay, you just give it to, this is S1, S2, S3. If you remember, this is a S1 dash, S2 dash, S3 dash. Okay, so from this digital multimeter, okay, so after giving main supply, you must turn on this knob. Okay, this is the knob, supply knob for this transmitter. So for in the first part of your experiment, you are not going to touch the receiver, synchro receiver. Okay, so you have to do nothing with the synchro receiver. You just forget about the synchro receiver. Okay, just concentrate on the synchro transmitter. Turn on the supply of this synchro transmitter now. Okay, so of course before, of course, even after turning on, you can give connections, no problem in this segment. Okay, so from this voltage digital multimeter, from this knob, give connection to this terminal. Okay, S1 terminal. Okay, you have to note down the voltages across. You have to note down the voltage across what? S1, S2, then S2, S3, then S3, S4. Okay, you have to note down the voltage across S1, S2. So connect this digital multimeter phase and neutral terminals. This terminal to S1, this terminal to S2. Okay, this terminal to S1, from this terminal to S2. So you have connected the voltmeter across S1 and S2. Okay, you have connected the voltmeter across S1 and S2 now. Okay, so initially let us assume this indicator or the pointer is at 0 position. Okay, at 0 position. Okay, at 0, so the angular displacement of this rotor, okay, is 0 initially. Okay, the angular displacement of this transmitter rotor is 0. So let's assume initially it is at 0 position. Note down the voltage if it is showing any reading. Okay, if the volt digital multimeter shows any reading at 0° angular displacement, note down the voltage between S1 and S2. Okay, you have given connection from this knob to S1 and this knob to S2. Okay, now, okay, and you just note it down in the tabular form. Okay, so for 0°, okay, so for 0°, note down the voltage between Vs1 and Vs2. Okay, whatever voltage that is displayed in the digital multimeter, in this digital multimeter, note down the voltage. Now, okay, now change the angular position to 10° or 20° or 30°. Okay, so okay, so you just change the angular position. Let us assume we have changed this angular position to 30°. Manually, you just vary this knob with your hand. Okay, so this pointer should be on 30°. When it is at 30°, you can note down this voltage in between S1 and S2 in this tabular form. At 30°, note down voltage between S1 and S2. Okay, similarly, with the help of this knob, now vary the angular position of the rotor. Okay, what are you doing here? You are varying the angular position of the rotor of your transmitter. Okay, this is the rotor of the transmitter. You are varying the angular position of the rotor of this transmitter. Now vary the angular position of rotor of the transmitter to 60 degrees. Whatever voltage is displayed here, just note it down in your tabular form for 60°. Okay, and similarly, you vary the voltage angular positions with the help of this pointer. Okay, up to 360 degrees. Okay, up to 360 degrees, and note down the voltage across Vs1 and Vs2. Okay, so voltage across S1 and S2 in general. Okay, just note down the voltages. Now you can simply remove okay, better if I show this image. Now remove the, you have given initially, you have given connection from this digital multimeter to S1 and digital multimeter to S2. Now give connection across S1 and S3, or S2 and S3, your wish, it doesn't matter. Okay, leave S1. Okay, now give connection between S1 and S3. Okay, and note down the voltage starting from 0°. Starting from 0°, note down the voltage. For 0°, when the connection is given between S1 and S3, okay, S1 and S3, S1 and S3. Now connection from this digital multimeter, you have given connection to S1 and S3. Now for 0°, note down the voltage. Okay, for 0°, note down the voltage. Again for 30°, note down the voltage in between S1 and S3. Okay, this last column. Okay, next, now give connection between S2 and S3, from this knob to S2, from this knob to S3. Okay, from this knob to S2 and this knob to S3, give connection, and again you start with 0°. Okay, you manually vary this pointer. Okay, bring it back to 0 and vary up to for 0°. Note down the voltage between S2 and S3 from this digital multimeter. Now vary this. It will this reading will change. Vary this to 30°. Note down this voltage in between S2 and S3 from this digital multimeter. Again vary to 60°. Note down voltage between S2 and S3 from this digital multimeter. Okay, so voltage between S2 and S3 for different angular positions. Okay, you just note it down from the this digital multimeter. Okay, so you will get some values. You can vary the angular position of this transmitter, this synchro transmitter. You can see it is written here up to 360°, and you can note down all the, you will get different voltages. Okay, for different angular positions, you have got Vs1, Vs2, Vs2, Vs3, Vs3, Vs1. Okay, so you have got different voltages for different angular positions. Now plot the graph. Okay, now plot this graph. You will get this graph. This is the synchro transmitter characteristics. Okay, this is the voltage waveform for Vs1 S2, Vs1 S3, and Vs2 S3. Okay, these are the voltage waveforms that you will get. This is one part of your synchro experiment. Okay, so let us go to the next part. In the next part, what you have to do is, so next part is the study of synchro transmitter and receiver pair. Okay, next part is you have to study the synchro transmitter and receiver pair. In the 6 month, you will determine the angular error. Okay, so in between the rotors. Okay, rotor angular error in between the rotor angular position of the transmitter and rotor angular position of the receiver. Okay, so you must not touch the this pointer of this synchronous receiver, okay, or rotor. It indicates the angular position of the rotor of the synchro receiver. Should not touch this. You must once again touch only this knob, which is the which indicates the rotor angular position of the synchro transmitter. Okay, so this indicates the rotor angular position of synchro transmitter. This indicates the rotor angular position of synchro receiver. You should never touch this pointer. Okay, you should never touch this pointer. Wherever, in whichever position it is, you just leave it as it is. Okay, you just leave it as it is. Okay, now what you have to do is, initially you must give connections. Okay, what you have to do is you must connect S1 of this synchro transmitter to the S1 or S1 dash of synchro receiver. Okay, you must connect with the help of patch cords. Okay, so you must connect S3 of synchro transmitter to the S3 of synchro receiver or S3 dash of synchro receiver. Okay, similarly connect S2 of synchro transmitter to the S2 dash or S2 of synchro receiver. That is this. Okay, S1 must be connected to S1 dash, S2 must be connected to S2 dash, S3 must be connected to S3. Okay, you must give connections in between. Okay, I don't have enough. Okay, of course, S1, S2, S3, S1 dash, S2 dash, S3 dash. Just join them. S1 to S1 dash, S2 to S2 dash, S3 to S3 dash. Okay, so you must join these terminals using patch cords. With the help of patch cords, just connect them. Okay, now. Okay, after just these are the three connection. No need of any digital multimeter for the second set of second experiment which you are going to perform. Okay, so you just want to observe the angular error in between the angular displacements of rotor of transmitter and the rotor of receiver. So simply connect S1 of transmitter to S1 of receiver, S2 of transmitter to S2 of receiver, S3 of transmitter to S3 of receiver. Now start with the zero angular position. Okay, so forget about the digital meter. We are not going to use any digital multimeter here. We don't want that. Okay, we are doing the second experiment, but I'm showing you this slide. Why? Because in this slide you can clearly observe the angular positions of this synchro transmitter. That's why I'm showing you. Now you have given connections in between S1 of transmitter, S1 of receiver, S2 of transmitter, S2 of receiver, S3 of transmitter, and S3 of receiver. Now start with 0 degrees. Okay. So you start with 0 degrees. So at 0 degree angular position, note down the angular position of the receiver rotor or rotor angular position of the receiver. Okay, so when this indicator is or the pointer is at 0 position, this pointer may be at the 0 position or may not be at the 0 position. You should not touch it and you should not adjust the angular position of the rotor of the receiver. Okay, so you just note down the angular position of this. Okay, wherever this pointer is indicating, you just note down that angle. Okay, so now vary this pointer to 30 degrees. Okay, of the this is the rotor angular position indicator of your transmitter. So vary the rotor and this angular position of the transmitter rotor to 30 degrees. When it varies to 30 degrees, this pointer will also automatically move to some other angle. It may be 30, it may not be 30. Whatever angle it shows, you just note it down in your tabular form. Okay, so this is the tabular form. These are the transmitter angular position, rotor angular position. You are manually you are varying, but receiver angular, rotor angular position you are not varying. Okay, so whatever angular position it shows, you just note it down as it is. Okay, so it may be for 0 degree of transmitter angular position. When you vary it with your manually, when you vary it when you keep this pointer at 0 degree, receiver this receiver may also show 0. When this is at 0, this may also show 0. If it shows 0, just note down 0. If it shows some variation, 1 degree, 2 degree, 3 degree, or 10 degree, okay. If it shows 10-degree variation, okay, even though you are not going to vary this, it may automatically vary. You just note down in this tabular form, okay. And you just see the difference between these two angles. If this is 10 degree, this is 0 degree. What is the difference? 10. Difference of 0 and 10 is 10. Error in the angular position is what? 10. Okay. Now vary the angular position of the transmitter to 30 degrees. Your wish, no need to exactly move it to 30. You can go for 10 degrees, 20 degrees, your wish. Okay, so you can just I'm telling some value here, that's all. Okay, so you just vary this pointer to 30 degrees. When this pointer of the synchro transmitter varies to 30 degrees, okay, so this receiver will vary to some angle. It may be 30, it may be less than 30 or more than 30. Okay, so it may be 40, we can't say. It may be 35. Okay, so when this is transmitter and rotor angular position is 30 degree, receiver angular position may be 35 degree or 36 degree, 37 degree, whatever it is. Okay, note down that value. Take the difference of these two. If it is 37 degrees, 30 and 37 degrees means difference is 7 degrees. Now note down the error in the angular position of this rotor. Okay, of the receiver. Okay, so similarly, you must vary this synchro transmitter rotor angular position gradually for different angles, and you must note down the rotor angular position of the receiver, which varies automatically without means without, you should not never touch this pointer while doing the experiment. Okay, and you note down the difference in the angular positions of these two as the error in the angular position. Okay, after that you must plot the graph. After noting it down for different angular positions of transmitter, note down the receiver positions and write down the error in the angular position. Means the difference between these two angles is the error in the angular position. Okay, now plot the graph for angular position of the rotor of the receiver in degrees by angular position of the rotor of the transmitter in degrees. Means, okay, already angular position of rotor of the transmitter, you already know it is, you are manually varying it. Okay, so you know the values. Receiver position, whatever you get. Okay, so for the angular position of the rotor of the, for different angular position of receiver, so you take some scale, your wish, on the y-axis and on x-axis also. You take some scale. Of course, both are angular positions, so scale should be uniform on x-axis and y-axis, and you will get a plot like this. Okay, so this is our experiment. So precautions that are to be followed in this during this while doing this experiment is, you must handle the pointer for both the rotors in a gentle manner. Of course, you should never touch the rotor angular pointer, angular position pointer of the receiver. Okay, you should not touch it. Okay, but they are very delicate. They are very delicate. Okay, they will be very delicate. If you are harshly holding it, then it may break down. Okay, you must carefully handle it and do not attempt to pull out the pointers. You should never attempt to pull out the pointers, and do not short the rotor or stator terminals. You should never short the rotor or stator terminals. Okay, so the result is the synchro transmitter and receiver pair was studied and graphs are plotted. Okay, this is the characteristics of synchro pair.